Hello, good afternoon, good evening, and good morning. Today we're going to learn about what happens when two lines are parallel, what sort of interesting consequences arise. So, let's just say that I tell you, and I might tell you in a sentence, or I might say it's given, that A is parallel to B. By the way, this is line A and this is line B. First thing you got to do is you got to react to that. You need to mark in that A is parallel to B. You do that using a couple of these little line things. If you want, you could do 2 and 2 to show that those two lines are parallel. That's the symbol we use for parallel in marking up our diagrams. You must always mark up your diagram first. Now, let's say I also gave you, someone's driving too fast outside. Let's say I also gave you that angle was 70 degrees. There's actually a lot that we can do. We can, even on the first day of school, we could have said, oh, that's 70 degrees because vertical angles are congruent. We could have also said, well, this is a straight line. If that's 70, we got to go 110 more, because remember that makes 180 to make a straight angle. You could then say by vertical angles or by a straight angle adding to 180, that last angle is 180 degrees. You could have said that on the first day of school. So now what's interesting is you can figure out a lot more information in this diagram because the two lines are parallel. Imagine you could copy and paste or lift all of this information and just plop it right here. What's cool is since the lines are parallel, you can do that. Since these lines are, never intersecting, then this kind of really is drawn to scale. If you just draw straight lines and these two lines are parallel, this example is drawn to scale. You could literally copy and paste this and plop it down here, and you'd have B being right on top of A, and then all the measurements, corresponding measurements, are just going to fall into place. That's like a cool little thought experiment. You should truly believe that. So then I could just plug in all the angles down here, and what's cool is since the lines are parallel, I can actually just do that. You should believe that this, if I were to cut it out and plop it right on top here, A would be right on top of B, and then all the angles, they really, they would all kind of line up. Well, now what we can do is, now that we've done that thought experiment, we've figured out the measures of the missing degrees. We were given that A was parallel to B. We were only given one angle measure. We figured out all 7 other angle measures. You should be able to do that when you're told that two lines are parallel. But now we can go further. Based on the last video, you can actually look at interesting relationships. So if two lines are parallel and cut by a transversal, okay. So we should always mark in that the lines are parallel. Also, on every problem, identify, mark in, label your transversal. And as a reminder, a transversal is a line that crosses through two other lines. It brings them together. It unites them. The transversal is crucial. So a transversal is a line that cuts through, in this case, two parallel lines, two or more, really. Okay, so we've labeled our transversal. Now we can start to look at some interesting factoids. Let's say that this was we call this angle 1, angle 2, angle 3, 4, 5, 6, 7, and 8. What's really kind of neat is now we can start to look, based on the last video, we can kind of like name interesting things. So I would recommend you do this again on your own and kind of pause it. But so if you look, I notice something interesting. I notice angle 1 and angle 6 are the same. So then what you're going to want to do is, and this is what you would pause and redo on your own, repetition is key, you would say to yourself, well, what sort of angles are angle 1 and angle 6? Well, you would pause it, and you should notice that they are corresponding angles. What do you notice about corresponding angles if two lines are parallel and cut by a transversal? Corresponding angles are congruent. Let's look at another set of corresponding angles. Remember, they're related in a special way. Like this and this are corresponding angles, these two angles, angle 2 and angle 5, because one of them is on the exterior, it's outside of A and B. One of them is on the interior, but they're both on the same side of the transversal. That's what makes them corresponding angles. So they're congruent as well. The measure of angle 2 is the same as the measure of angle 5. Okay, so corresponding angles are congruent if the lines are parallel. Let's observe more. Well, in here, this is the inside. On opposite sides of the transversal, we call that alternate. And remember we said they were on the inside. Alternate interior angles, they are congruent as well. There's even one more. Oh, and let's just verify that. So similarly, this 110 degree angle and that 110 degree angle, those are alternate interior angles because they're both on the inside, the interior of A and B, and they're on opposite sides of the transversal. So alternate interior angles are congruent. And now, last but not least, alternate exterior angles are congruent. Try and see if you can find a couple of pairs of alternate exterior angles. They're on opposite sides or alternate sides of the transversal. And they're both on the outside. Here's the interior. They're both on the outside of A and B, and they're on opposite sides of the transversal. They are also congruent. The measure of angle 1 is the same as measure of angle 7. The measure of angle 2 is the same as measure of angle 8. They're both 110 degrees. So apparently all of these things are congruent. So you might say, oh, if lines are parallel, everything's congruent. Not quite. I also notice that some things are supplementary. And I'm going to abbreviate here for supplementary. There are a couple types of angles that are supplementary. Remember, supplementary means adds to 180. One thing that's interesting is if these two angles, 1 and 8, they're on the same side of the transversal. They're both on the right. And they're both on the outside because here's the interior. Those same side exterior angles, like the measure of angle 1 and the measure of angle 8, 70 plus 110 makes 180. Oh, that's interesting. Same side exterior angles are supplementary. Same thing over here. These two angles, the measure of angle 2 and the measure of angle 7, those also both add up to 180 degrees. So that's interesting. Same side exterior angles are supplementary. Similarly, same side interior angles are also supplementary. Let's look at that. Same side, interior. Interior would mean in here. Same side would be like they're both on the left of the transversal. Oh, angle 4 and angle 5. They do add up to 180, so they are supplementary, and they are same side interior angles. So then you might say, well, how am I going to know or remember all this? Well, you have to chunk it in your mind. If you're given two angles, they're either going to be congruent or supplementary. How are you going to remember the difference? Well, I noticed that same side angles, whether they're on the interior or the exterior, are supplementary. Notice how there's a lot of S's there. That'll help you kind of formalize that in your mind. Otherwise, if you have any sort of angles up here, the angles will be congruent. So you now, if you're given that two lines are parallel, if you're given this, you can actually kind of go crazy on your diagram. You can really mark in lots of interesting things. So in this example, you should always react to the givens. You got to mark it up on your paper. You're given that A is parallel to B. Mark that in right away. Okay, so A is parallel to B. Now you have to ask yourself, wow, well, I need to solve for X. What sort of angles have I been given? And you really need to call them by name. Identify your transversal. I recommend you do that first every time. So here's your transversal. It's bringing together A and B. It's cutting through A and B, so it's the transversal. These angles have a name. They're both on the same side of the transversal, but one's in the exterior and one is in the interior. Now, to say all the words I just said, that's just way too much work. So I notice that they're related in a special way. We have corresponding angles. Corresponding angles are congruent if A is parallel to B. So, and I know that I did not write a sentence there. I just kind of sketched an idea in this video. But, you know, if the directions say to explain, you'd have to write a full sentence. Say, since A is parallel to B, and we are given corresponding angles, we know that they are, in fact, congruent. Corresponding angles are congruent. If you don't remember, look at the last slide. So, then you can justify, that's your explanation for this algebra right here. Okay, so in order to get full credit on this video, you will actually have to do the legwork and solve this out. This stuff right here is the new information where you're looking at parallel lines, seeing what you're given, and realizing that corresponding angles are congruent. But from here, ladies and gentlemen, this is a factoring problem. You must solve for x. This is part of your homework. Good luck. Also, make sure you plug in and actually find all of the missing angles, because you can actually get all 8, just like we did on the last problem. Good luck. Also, just to show that you're watching this video super carefully, right in the bottom right corner of this slide, could you please put the last letter of your first name? That's just going to show us that you're paying attention to details. Otherwise, you're not going to get full credit on this video because you have to listen carefully. So make sure you factor this out. If you can't factor, go back and watch the video on quadratics that I did a couple units ago.